This is the fourth section of the parametric equations chapter. This is to do with points of intersection, and basically all you need to remember that if you want to find out where a graph crosses the x-axis, so x-axis crossing points, or the intersection with the x-axis, what you need to do is to make y equal to 0, which normally means if you've got it as a parametric equation, it will be, let's say, if y equals some function of t, like that, f of t, so you just make that function of t equal to 0. If you want to find out where a graph crosses the y-axis, its crossing point, its point of intersection, then you make x equal to 0. So if we had x equals a different function of t, then we would make that function of t equal to 0 and solve it. So here's our parametric equation. Here we have an unknown value of a, which we need to find in part A, but we're told that this parametric equation produces this curve C that passes through the point negative 4, 0. Now what does that mean? What that means is that when x is negative 4, we'll get this, at the same time y is 0. So that gives us this equation here. So it's all about trying to solve these equations simultaneously. So all I've done here is replace the x with negative 4 and the y with 0. So if I'm going to solve the equations, I can't really solve the second one at the moment. I suppose I could put the 4 across and factorize, maybe, but it seems a bit easier to solve this one over here because it's equal to 0. So what does that mean? That means either a equals 0, I'm going to factorize this, or t cubed plus 8 equals 0. So if t cubed plus 8 equals 0, that means t cubed equals negative 8, which then means that t equals negative 2. So at this point, negative 4, 0, t is negative 2. Okay. If I then put this value of t equals negative 2 into this equation, I should be able to work out a value of values of a. So let's do that. So I've got negative 4 equals a times by negative 2 squared plus negative 2. So we'll tidy that up. So that will give us negative 4 equals 4a minus 2. So in which case I would add, I would add 2 to both sides. I've got negative 2 equals 4a, so a equals negative a half. Okay, so I've now got my values of a, but the question says a is non-zero, so we forget about this value of a. We're only interested in this one here. So that's part A done. Let's move on to part B. And on part B, it says find the coordinates points A and B, and I'll just highlight those on the diagram. That's here, and no, it's there and there, those two, where the curve crosses the y-axis. Right, so if it's where the curve crosses the y-axis, let's do part B down here. So where it crosses the y-axis, that means that we make x equal to 0. So now we can write our new equations because we know the value of a is negative a half. So our parametric equations become x equals negative a half t squared plus t, and then the other one is going to be y equals negative a half times by t cubed plus 8. So we're making x equal to 0. So that means that we've got 0 equals negative a half t squared plus t. That we can factorize. So we'll have t negative a half t plus 1, which then means that t is either equal to 0 or t is equal to 2. So that gives me the two values of t where the graph crosses the y-axis, and now I can use that to work out what the y coordinates are at those points where it crosses the y-axis. So I can now substitute in those values of t. So let's over here substitute in the t equals 0, over here the t equals 2. So over here, if I substitute in t equals 0, so negative a half, 0 cubed plus 8. So that gives me y equals negative 4. And over this side, if I plug in the t equals 2, so that's y equals negative a half times by 2 cubed plus 8. So that's going to be 8 plus 8, which is 16. Half of 16 is 8, so I'm going to have negative 8. So if I'm going to write down the full coordinates of A and B, A is going to be the one where y is negative 4 because it's higher up. So A equals 0, negative 4, and B equals 0, negative 8. Right, here we have another set of parametric equations here. And it says the line x plus y plus 4 equals 0 meets the curve at A. Find the coordinates of A. So this is about finding where this parametric equation and this equation, where they meet. So step number 1 is actually to turn the parametric equation into a Cartesian equation so that we can solve simultaneously. So I would probably make t the subject of this one. So I've got t equals y over 4. I would then substitute that into this one over here. So I've got y equals, or x equals y over 4 all squared. I can leave it like that. And actually it might make sense to leave it like that because now I want to substitute that. I'm going to sub into this x plus y plus 4 equals 0, and I can do that because I've written that x equals something, so I can replace the x with y over 4 all squared plus y plus 4 equals 0. So let's solve this and see what we get. So it's looking like it's going to be a quadratic. So if I expand the brackets, 1/16 y squared plus y plus 4 equals 0. What I can do, if I want to attempt to factorize it, I'd probably multiply everything by 16. Get rid of that 16th there. So I've got y squared plus 16y plus 16 times 4, 64 equals 0. I think that's going to give me 8 and 8 in the bracket. So y plus 8 or y plus 8 in brackets all squared equals 0. So what does that tell me? That tells me where these two, the parametric equations and the line cross each other. That is where y equals negative 8. So I want to find out what x is. So to do that, I can just substitute that negative 8 into my equation. So I'm going to sub into the equation x equals y over 4 all squared. So let's do that. So we'll get x equals negative 8 over 4 all squared. So that's going to be negative 2, and negative 2 squared is 4. So I now have the y coordinate where they cross, the x coordinate where they cross. So really, if I'm going to finish this off nicely, I would write down that the coordinate of A equals 4, negative 8. And it's always good practice to clearly mark your solutions so the examiner knows where your answers are. Okay, so I would suggest the most straightforward way of doing this question is to substitute this value of y here. So I'll have pi squared equals that. Use that to find t. And then once we've found t, what we can do is then substitute that into here to find out what the x coordinate is. We know the y coordinate is pi squared. What's the x coordinate? Okay, so let's substitute that pi squared into that equation. So that means we'll have, rather than y equals t minus pi over 6 all squared, we'll have pi squared equals t minus pi over 6 all squared. From there, what we're going to do is we're going to square root both sides. Now, because I'm square rooting, I need to say plus or minus. I don't need to write plus and minus on both sides. Doing it on one side is enough. That will get you all the solutions, but don't forget on this one that we need to put the plus or minus. That will give us two equations to solve. One of those equations will be pi equals t minus pi over 6, which we're going to solve, and the other one's going to be negative pi equals t minus pi over 6. So let's solve them, and we can solve them by adding pi over 6 to both sides. So if I've got pi plus pi over 6, that's going to give me 7 pi over 6, so t equals 7 pi over 6. And for the other one, if I have negative pi and I add pi over 6, that's going to give me negative 5 over 6 pi. So negative 5 pi over 6. So this is what I'm interested in. These are my two values of t. So I found my two values of t. What did I say the next thing I was going to do? Well, I'm going to substitute those into x to work out what the values of x are. So x equals cos t plus sine t. So let's sub in the t is 7 pi over 6. So that will give us x equals cos 7 pi over 6 plus sine 7 pi over 6. And if we sub in the t equals negative 5 pi over 6, that will give us x equals cos negative 5 pi over 6 plus sine negative 5 pi over 6. So what we'll do here, we'll just do this on our calculator and find the answer. Because we have pi there, we need to make sure we're in radians. So cos 7 pi over 6 plus sine 7 pi over 6. I get a fairly straightforward answer in a third, which is minus 1 plus root 3 over 2, like this. You could change it to a decimal, but it is a fairly straightforward answer. And well, the question doesn't say give the exact point, in which case you would leave it as a third, but I'm sure you could leave your answer to at least 3 significant figures. So I'm just going to go back and edit where I put my numbers in and change them to negative 5 pi over 6. I've done the sign. I'll go back and change it to negative 5 pi over 6 and see what we get. And we get exactly the same answer. So negative 1 plus root 3 over 2. So there is only one point of intersection, and that's going to be this coordinate, negative 1 plus root 3 over 2, or its decimal equivalent, comma, pi squared. Part B, we want to find out where the graph cuts the y-axis. So that means we make x equal to 0. So we take the x part of the parametric equation. So that will give us 0 equals cos t plus sine t. And we'll rearrange that to see if we can find t, and then we substitute that value of t, or those values of t, into the y part of the Cartesian equation. So if I were to take cos away from both sides, so negative cos t equals sine t. If I divide both sides by cos t, like this, cos t, that gives me negative 1 equals tan t. So let's do the tan inverse over here of negative 1 to find out what t is. And we get negative 1/4 pi. But because of the range in the values of t here, there could be another value of t that solves this equation. So we need to do a cast diagram. Let's do one here with the pen, not the highlighter. So cast diagram here like this, and we've got an angle of negative pi over 4, which is like negative 45 degrees, which is here, negative pi over 4, CAST. Our value of tan is negative. Where else is it negative? Over here. And we have this cross like that. So this is a gap of pi over 4. So according to my cast diagram, this other angle would be pi minus pi over 4, which is 3 pi over 4. And actually that's in the range here, isn't it? So actually there's another solution. So I've got t equals negative pi over 4. That's fine. And also t is 3 pi over 4. So now we're almost done. The next thing that we need to do is substitute those values of t into the y part of the parametric equation to work out what the y values are of these points A and B. Right, so let's start with y equals negative pi over 4 minus pi over 6 all squared. That's where we substitute that into there. And then we're going to do the same thing here. Y equals 3/4 pi minus pi over 6 all squared. Let's work out what our two values of y are. So the first equation over here gives me an exact value of y equals 5 over 12 pi all squared. Now my calculator gives a decimal answer. If you just square it by inspection, then you'll get 25 over 144 pi squared, if you want it exact. Now the other value of y you get is 7 over 12 pi all squared. And again, if you want to give that answer exact, that'd be 49 over 144 pi squared. So I've run out of space. But if I just highlight here the actual y coordinates of A and B, actually let's write it at the top here. So A is going to be 0. Now we need to use a bit of common sense. A is the one that's lower, so it's going to have the smaller y value. So that's the 25 over 144 pi squared. So that means B is going to be the one with a bigger y value because it's higher up, 49 over 144 pi squared. Right, you should now be able to do exercise 8D on pages 211 to 213 of the textbook.